Hello AI class students. This will serve as a practical example of a very trivial neural network. There's plenty of instructional material about neural networks. This will be a practical introduction to a one-neuron neural network which computes a very simple function. And the idea that this is going to be a neural network which is going to figure in your homework. You will train this neural network on paper instead of programming it in order to see, generally speaking, get a feel for how this all works. So the neural network in question is going to compute logical and, as in, true and false is false, true and true is true, that type of logical and. Since neural networks have numerical inputs, we're going to have two inputs, x1 and x2, where 1 is equal to true and 0 is equal to false. So if we take a look at how this network is supposed to behave, we have our cases, our truth table, where false 0 and false 0 is equal to false. False and true is equal to false, true 1 and true 1 is equal to a true 1, like that. So think of this truth table as the data we're going to use for training the network until the network properly takes two inputs and produces the right and output. So this is going to be one neuron network. I drew it up here with ASCII art. And x1 is the first variable, has a weight, and the network computes x1 value times the w1 weight. x2 has its weight associated with it, w2. It computes x2 times w2. Those two products go into the neuron, which adds them up. So it's x1w1 plus x2w2. And this is what pretty much all neuron models do. And then they have what's called the transfer function. The transfer function is how do you get from that sum of the weighted inputs to an output. And here we just have a simple step function. And the step function says if the sum is greater than or equal to 0.2, the neuron outputs a 1, true. Or if it's less than 0.2, it outputs a 0, false. So that is the simple one-neuron neural network with two inputs, two weights, a simple step function or a transfer function. Note that when we start this thing, we're going to have random values for the weights. That's pretty usual. And then with training, those weights will get adjusted until the network behaves properly. That threshold value of 0.2 would be a trainable parameter. But in this simple example, we're going to just hold it at 0.2. We're not going to try to adjust it. That's the network. And we can easily see how it works over here in this spreadsheet. So let's imagine for a moment that we are giving it two inputs of 0 and 0, false and false. All right. 0 times w1 is 0. 0 times w2 is 0. The sum is 0. 0 compared to 0.2 is going to be less, so out comes a 0, and that is correct. So that's the correct output. We're happy. Well, let's give it the next line on the truth table, which is 1 and 0. So x1 is a 1, x2 is a 0. We multiply 1 by 0.3. We add it to 0 times that. We get 0.3, right? So 0.3 is greater than 0.2, so the output will now be that 1. Now, true and false should be false, which is 0. The correct output in the truth table here was a 0. Now, what's the error? So it's tempting to say the error is 1 because we are 1 away and we wanted a 0, we got a 1. So the error value is 1. We're off by 1. Actually, we're going to say the error is -1 because the error is going to help us correct the problem. So this -1 is how much do we need to change to get back to the correct value, as opposed to how far did we deviate from the correct value. The arrow is pointing towards the correct value, which from 1 minus 1 becomes 0. So think of the error as, pointing at the correct answer. So this error value is then going to be used for adjusting the weights. And how we do that and how you do your homework is going to be the subject of the next video. So, thank you.